Hi, I'm Jaimie.
Hi, I'm Loren. We hope that you will enjoy our second assignment for Chemistry in Our World. Our assignment is on silicon-based life. All living things that we know of have things in common. They grow, reproduce, and respond to stimuli. Take this stock image butterfly, for example. Additionally, they share the same biochemistry. They're made up of long chains of carbon molecules. But could non-carbon instead of silicone-based life exist? Silicon and carbon have a lot of similarities. They're in the same family in the periodic table, and as you can see, carbon is just one row above silicon. From their outward appearance, you couldn't really tell them apart. I mean, look at all these lovely rocks. Can you tell which one's carbon and which one's silicon? I can't, that's for sure. A very special thing about carbon is its 4 valence electrons, which are perfect for forming bonds in very long chains. These long chains are the perfect building blocks for molecules complex enough to keep living things alive. But carbon isn't the only element that can do this. Silicon shares many of the same properties as carbon. For example, just like carbon, silicon has 4 unpaired electrons, which means it can make 4 bonds, and it can also form chains bonded to other elements, for example, oxygen, just like carbon. With all these similarities between carbon and silicon, one might wonder, well, why isn't silicon-based life just as abundant on Earth as carbon-based life? That's because there are a couple of very important differences. A lot of the bonds formed by silicon are weaker than those formed by carbon. Especially in the silicon-silicon bonds that would be needed to make long chains, they just don't really exist. Additionally, when silicon-silicon chains are formed, they're generally unstable in the presence of oxygen, which would be very unfortunate for any living organisms. Additionally, it would also be possible that even if silicon-based life existed, we as humans would not recognize it as such, since in all likelihood silicon-based life would look nothing like other known life that we have on Earth. Silicon-based organisms would also possibly react very strangely in an Earth-like environment. For example, when silicon reacts with oxygen, it turns into quartz, which would be very unfortunate for many organisms if they lived on a planet like Earth. Furthermore, silicon-based bonds are most stable at high temperatures, so if silicon-based life did exist, the best place to look for would be in hot places, like deep beneath Earth's surface or on hotter planets. Still, silicon-based life would probably not be very complex, due to its unstable bonds. But let's ignore present-day science for a minute, and instead look towards the future of silicon-based life in relation to science and exploration, as well as media's portrayal of silicon-based life.
Despite the lack of evidence to support the idea or existence of silicon-based life, science fiction writers have had a lot of fun with this idea. Take Star Trek, for example. In one episode, Kirk and Spock run into a tunnel-dwelling silicon-based creature that's terrorizing miners on an alien planet. However, organisms with such different biochemistry might be very hard to detect. So some scientists have proposed the idea that there could be some sort of shadow biosphere of non-carbon-based life living with us on Earth. After all, silicon is the second most common element in the Earth's crust after oxygen. That silicon, however, is bound in rocks, which would make it difficult for organisms to bound it into their biochemistry. If silicon-based life on Earth does exist, another possibility would be for it to take the form of silicon-based microbes living in magma deep in the Earth's crust. Aside this, our best bet for finding silicon-based life would probably be to just look elsewhere. A telescope that launches this year, called the James Webb Telescope, will look for signs of life in the atmosphere outside our solar system. Since photosynthesis and respiration affect the amounts of oxygen and CO2 in Earth's air, it's possible that silicon-based organisms could leave traces of their own existence in their planet's atmospheres too. Some scientists are also working towards making their own silicon-based life. In March of 2016, scientists announced that they had found a form of thermophilic bacteria with an enzyme that, in rare cases, incorporated silicon molecules into its carbon-based molecules. Using artificial selection, they were able to modify the bacteria to produce the molecules with silicon in them 2,000 times as often. Someday, artificially created microbes like this may be used to produce complex silicon molecules that chemical companies can turn into glues and sealants. Furthermore, a research like this also helps scientists understand more about how life can use silicon.
Thank you so much for listening to our presentation on silicon-based life.